Okay, so minors and cofactors are a convenient way of finding the determinant of a square matrix that is greater than 2 by 2. So we have to solve for minors first before we solve for cofactors, and what that is where you grab the entry of that number and you delete the row and column corresponding to that entry, and that's how you find your minor. So let me show you guys what that looks like as a demonstration. So let's say we are supposed to find a minor of a sub 21, which is in row 2, column 1. Here's what that is going to look like. Notice how we have deleted row 2 and column 1. And now we can denote the minor as m sub 21 equal to the remaining entries after delete row 2 column 1. And it turns out we have a sub 11, a sub 13, a sub 32, and a sub 33. From there we can take the determinant 2 by 2 matrix, and that's pretty much how you find a minor of a sub 21. Now what about the cofactor? Well, the cofactor is often denoted as C sub ij, which is the dimensions of the matrix, equal to negative 1 to the power of the sum of the two dimensions, I plus j, times the minor that you have deduced. And since we were looking for the minor of m sub 21, we can denote the C sub 21 equal to negative 1 to the power of 1 plus 2 times our minor, which is m sub 21. So negative 1 to the third power will always be negative 1. So therefore the cofactor of a sub 21 will be negative m sub 21. Now we've recently covered finding the minor and cofactor of a sub 21. What would that look like for the minor of a sub 22 and its cofactor? Go ahead and pause the video and figure that out based on what we have recently done. So when you're solving for the minor and cofactor of a sub 22, this is what you should get. So for the minor of a sub 22, we deleted row 2 and column 2, and we're left with the following 2 by 2 matrix. And for the cofactor, we know the dimensions are 2 for I and I for j, and therefore the cofactor a sub 22 is equal to negative 1 to the power 2 plus 2 times the minor of a sub 22, which ends up being m sub 22. So one quick thing to know is that minors and cofactors of a matrix can differ only in sign. To obtain the cofactors of a matrix, you had to first find the minors and then apply this checkerboard pattern of pluses and minuses. And I'm going to show you guys that eventually. And do note that odd positions, where I plus j equals an odd integer, tend to have negative signs. And positive integers are the result of even positions for I and j. So about earlier, this is the checkerboard pattern of pluses and minuses you should be aware of when it comes to obtaining the cofactors of a matrix. And as you can see, regardless of the size of the matrix, it's going to alternate between positive and negative values. So now that we got the fundamentals down, let's now begin with a numerical example. So what if we were tasked to find all the minors and cofactors of this given matrix? Well, what we can do is that we can start looking for the minors. And in this case, row 1, column 1, we have m sub 11, which is equal to, well, the deletion of row 1, column 1, and we are left with the following 2 by 2, and that is simply this operation where the minor ends up being equal to -1. Now, what about m sub 1, 2? Well, when we're looking for m sub 1, 2, we are deleting row 1, column 2. And as a result, we get the following square matrix of 3, 2, 4, 1. And as a result, we get 3 times 1 minus 4 times 2, which is equal to -5. Okay. Now what about m sub 1, 3? What does that look like? Well, it simply means we have to delete row 1, column 3, and we're left with the square matrix of 3, 1, 4, 0. And that just becomes 3 times 0 minus 4 times 1, which ends up equaling 4. And yes, I cut myself midway through that it was supposed to be -1 in the minor. Now this is only a third of the minor supposed to solve for. So we have to solve for minors in the second and third row, and that's simply 6 more we have to look for. Go ahead and pause the video and do it yourself, and I'm going to cut to what your minor should be for the remaining. So these should be your remaining minors, and now that we got the minors solved for and taken care of, we now have to look for the cofactors. To find the cofactors, we'd have to combine the minors with the checkboard pattern for a 3x3 matrix. So let's work that out. So for a cofactor in row 1, column 1, that simply results in -1 times 1 plus 1 times the minor of m sub 1, 1. We already know the minor was -1, and -1 to the second power will be positive. So that just leaves us the cofactor of -1. Now what about c sub 1, 2? That's simply -1 times 1 plus -1 to the power 1 plus 2 times the minor of m1, 2. Mathematically, that is going to be 5, since our minor of 1, 2 was -5, and -1 to the third power will be -1. Here's one more cofactor I'll do with you guys. We have c sub 1, 3, which is equal to -1 to the power of 1 plus 3 times the minor of m sub 1, 3. So -1 to the fourth power is going to be +1, and m sub 1, 3 will be, was 4, and the cofactor resultantly will be 4. We've done a third of the cofactors we were supposed to find. Go ahead and solve for the remaining 2/3. Pause the video and figure it out yourself, and in a few seconds I'm going to cut to the remaining solutions. And these are your remaining cofactors. So we've covered the fundamentals of minors and cofactors, and we've gone over a numerical example. Hopefully this helps, and good luck you guys on your journey.